Today we will solve LeetCode 973. It says k closest points to origin. So here we are given a 2D plane, and in 2D plane we have a notion of points, and all the points will have two values, the value corresponding to x-axis and y-axis. So you are given a set of points in this 2D plane, and the origin is here at coordinate 0, 0. So origin is also a point in this same plane. Only thing is that its x and y both coordinates are 0. So you're given a bunch of points. There will be more points. Each will have two values, x1 and y1. You have to select k closest points to the origin. So there are 10 points. Let's say you want to find 3 closest points. Then you will pick maybe this point, and this one. So first let's understand how to measure the closeness to origin. So you're given x and y coordinates. Since this is two plane, only two axes are there, and here it's 0, 0, that is x and y both are 0. And if this is point P1, then this coordinate will be x1, y1. Each point will have two values, a pair, and this means that on x-axis, if you drop a perpendicular, it will be, this distance will be x1. Similarly, on y-axis, this projection will be y1. So what will be this value? Distance from origin, let's call it d. So you see that this is a right angle triangle, this one, and this angle is 90 degree. So we can apply Pythagoras theorem. Hypotenuse square, which is d square, is equal to base square. Base is this x1 square plus perpendicular, this length is y1. So we got the square of distance, and if some distance is positive, we take the square root of this, but we don't need to take the square root of this since we have two positive quantities, let's say d1 and d2, and we are given that d1 and d2 both are more than 0 or equal to 0. So both are positive or non-negative quantities, so their squares will also be hold the same relation. If d1 is greater than d2, then this will also hold. So we don't need to take the square root of this everything, we will avoid that. So this is the measure of distance from origin. Similarly, for other point, if this is P2, its distance will be x2 square plus y2 square. So in order to calculate the distance square, we will just take the square of their x and y coordinates. Now let's see how we will solve that problem. So we are given some points. Let's say these are the points. Order we don't know, these can be in any order in input. So you will be given values like that, like some xy value, some other xy value, and so on, as many points are there. So what we need to do, we need to find k closest points to the origin. So what we can do, we will pick the first k points, and total, let's say there are n points. We will pick the first k points and put them in a heap. We can put them in a min heap, or here we will need max heap. Let's see why. So what if we put k values in a heap? We have put everything in a binary heap, and it's a max heap, and the property is that the top will be the maximum value, and here we will build the heap based on their distance from origin. So these are the different distances. So this point, out of these first k points, this is the point with maximum distance from the origin. So we will start looking from this k plus first point all the way up till nth point. So we will see if this, what is the distance of this next point. If it's more than this, then we don't need to include it. We at the end of this loop, what is our target? To find k smallest distances. So very simple thing you can do before even moving to heaps, sort these points based on their distance. So you can provide a custom comparator, and all the languages have a notion of sort function, some built-in sort function, and it will have some default comparator, but you can provide a custom comparator the way you want to order things. So let's take two values as inputs, which are points P1 and P2. So this comparator will take P1 and P2 as input, compare their distance from origin, and then sort them in ascending order. So you have now sorted these points in ascending order based on their distance from origin, and pick the first k elements, and that's it. Return it. Order is not important. Return those k points in any order, and that should work. So what will be the time complexity of that sorting thing? In order to sort, we will need n log n time, and then for fetching the k elements out of that, we will need another k units of time. So overall it will be order n log n time, this sorting thing, and this would work fine. You can try it. I will also solve this sorting thing in any one language, C++. And now let's look at the other solution, which is using heap, which I am talking. So build a max heap of the first k elements. Now this is not sorted. This is the original input points array. So what will be our goal? That when we have iterated this entire list, we should hold a list of k smallest points. So this heap will always contain k points when we are building this, when we are traversing these points. So now it's containing first k points. Now I start looking at k plus 1 till nth point. And whenever I find a point which is smaller than this top, then we will remove this max and put that point here. So in that way, we will always be removing the maximum element. So till this k, this is the maximum. We want to keep minimums intact. We want to get rid of maximums. So when we have look at k plus 1th element, what will be the maximum of this k plus 1 elements? Max of k is this top root and this one. So whichever is the max among these, that is this root or this point, will be the maximum. And in heap we will not store that. So if root is maximum, we will remove it and put this point instead. And if this point is maximum, then we don't need to do anything. We will move to the next. So at any point of time, we will be holding k smallest elements. So what will be the time complexity of this? And once we have iterated all the points, we will just start iterating this, start popping elements from this max heap and start putting into our result, which will be again a list of lists, just the same format as input, and its size will be k. So let's look at this time complexity for building heap. If you build it using some build heap function, it takes linear time for n elements. But here we will use priority queue implementation, which uses heap. So we will do one at a time. So we will keep pushing one element at a time, and we will not build it at once. So for k elements, it will take let's say k log k times. Then for remaining elements, again we will be comparing with root, and if required we will insert it and remove it. So removing is trivial, it just removes the top element, and inserting will be log size of heap, and here we will be maintaining k elements, so it will be log k, and this will be done for this n minus k elements. So if you add these, it will be n log k. Log k is common, and this n minus k plus k. So this building heap, while iterating all the points, takes n log k. Now we need we need to pop each element one by one. So we will pop the top one and put it into result. So heap will become of size k minus 1. We will again pop from the top. So now we have to just keep popping and inserting into the result. So this will be done k times, and worst case, let's take log k, although it will be much less since we will be getting rid of many elements. So heap will become smaller and smaller. Now let's add these. So we will get n plus k log k. or k is here less than n, so it's n log k. So this is the difference in time complexity. If you just do sorting, it will take n log n time. If you do use this max heap formula, you will do it in n log k. So here there is a difference of log n and log k. Although in practical scenarios you will not find too much of difference, and both will be much closer to a linear time, since log n cannot be very much. So if n is integer, then even if it's a big integer, let's say 10 raised to the 2 raised to the power of 16, then what is log n? Log n is 16. So it will be close to linear only in practical scenarios, but for theoretical justification, this sorting will be in n log n worst case, and this heap will work in n log k. So this theoretically this looks better, log k. So let's write the code for this. In one of the languages I will use sorting also as an additional method, although that is very trivial. You need to use the inbuilt sorting function in different languages. So first let's solve in C++. So we need to define a comparator here, custom comparator. Let's call it compare points. And this should have just one method, bool operator, this operator. This is point 1. Point 2. So this point, every point will have just two values, this 0 and 1, you can see, x and y coordinates. So we had seen that the distance formula we will use will be this one, x1 square plus y1 square. So p1 0 denotes the x. So we took the square of this plus p1 1 times p1 1. So p1 0 is x, x1, and p1 1 is y1, and then less than this same thing, but it will be p2. So we have defined the comparator. Now we are ready to use sort. So what we will do sort points dot begin. This is the original input points, and points dot end. So we will sort everything, and then we need to pass optional comparator function. So here we will pass compare. Now it's sorted. So what we will do, we will build this result. And let's try. And this works for this case. Let's submit. And the solution is accepted. So you see this sorting thing is very small, but it's a valid solution, and we had seen that there is not too much of difference between the time complexities as well, since there is not too much of difference between log n and log k. Now we will see the heap problem. So we will use priority queue You can also use that make heap and make heap function, which is being used by this priority queue implementation as well, that same APIs. But let's use priority queue thing. It will be much more simpler to implement. Vector of int and container will be vector of int. And then the last one will be comparator. So let's call it PQ. So what we will do, we will store the first k points. So if pq.size is less than k, then we simply insert it into the priority queue. So pq.push this point, else we compare which is the maximum, the root of this priority queue or the new element or the new point. So whichever is maximum, we will not keep that in the queue, we will keep minimum. So top equal to pq dot top. So let's calculate its distance. Here we will calculate distance as distance square. So top 0 into top 0 plus top 1 and what is d2? d2 is the distance from origin for this new point, pt 0 if d1 is more than d2, that is the max distance point is in the heap, so we will remove that and insert this new point. pq dot pop and pq dot push this point. And now when this ends, this heap, this priority queue will hold k elements, k smallest elements. So we will do this same thing. Some typo here. So our answer is wrong here. So let's see why. So here we have, this is the mistake, I guess. We had added d1 is greater than d1, so this was never happening, and it was always keeping the first k elements only. So let's try it again. This time it's correct, so let's submit. And this solution is also accepted, this max heap based solution. Now let's do this same max heap based solution in Java and Python. It's as an exercise for you to try that sorting thing also. That should be 1 or 2 liner depending on the language. So in Java also we will define a custom class which will be implementing the comparable. So let's call it point implements. It has 2 values, x and y, the coordinates. So you need to implement this compare to method if you implement comparable. Now we have defined the custom comparator. Now we will use it. Priority queue. We will follow the same logic. We will insert first k points. I equal to 0, I less than points dot length, and the same check if pq dot size is less than k, then we will simply push it into the queue. pq dot offer new points I. So we have not yet put k elements, so we will keep pushing it. Else now the priority queue has k elements. So what we will do, we will push the minimum element, the minimum among the top of the queue and the new point that we want to insert. So this is the top maximum in the queue. If And that's it. After the end of this loop, it will hold k minimum elements in this priority queue. And now we will define our result. We could have also used this size of PQ, which is same thing as k. So this will return as well as remove the top element. And let's create the result of size. Size will be k and the second dimension will be 2. So it's new int and that's it. And the solution is correct. Let's submit. And it's accepted in Java. Finally, we will do it in Python. And again, you can use the sorted thing and use lambda function. And then you can sort it based on the distance. 0.1 square, 0.2 square. So this would be done in one line. Now here making the priority queue is a bit tricky. By default this priority queue or heap is min heap, and here we will be needing max heap. So here the trick is to use the negative of distance. If 5 is more than 3, then minus 5 will be less than 3. So we will make a heap out of negative of distance, so that way the negative of max will be at the top. So let's do that. So here PQ is a list. In Python we have this heap queue dot heapify, and it will expect one list to heapify, and here we need to create the list, and it will heapify based on the first element of each item. So a list can have many elements, and each element in themselves can have multiple components like x, y, g. In the case of points, we will have x and y. So it will heapify based on first of those elements. So we will create a new type of list where we will insert distance, then x, then y. So it will heapify based on distance, and that is what we want. So minus I times I minus j times j, and I and j will be the points while iterating these points. Beginning till k. So this is holding 3 values: the distance square, negative of distance square, then x coordinate and y coordinate. So we need to insert I and j also, since we will need these values in order to put them into the result. So we are keeping these values as well. Now this heap is holding first k points in this. So we iterate all the points from k till last index. And this is the distance of origin from this new point. First time it will be k plus 1th point. And if negative of pq 0 0, so what will be at the 0 0 position? The max element, since it's a min heap and we are storing negative of distance, so the maximum distance, that is, if we take the negative of every distance, that will be at the top. So this is the maximum distance in its negative, so we take the negative. Now this is the maximum positive distance, and if this value is more than d, then we need to get rid of this element from the heap. Remember that this is a distance is a dummy value, and we are not finally returning that in result. In return, we are just returning the x and y values, which we have not changed. So that will remain as it is. So what we will do, the same logic, we have not changed anything here. Heap q dot heap push pq, and we will be pushing the negative distance only. So it's minus of d we can write, and we will, next two values are x and y coordinates, and then we will heap q dot first element is distance, so we take dxy from pq and just take the values x and y, which are x and y coordinates, and we return the list of all those values in this priority queue. So let's try. Point is not defined. And this solution is accepted in Python as well.